All right. Today, my little Padawans, we are going to be doing something new. We are going to be dealing with trigonometric identities. All right. And before we jump into that, I want to do a little flashback. So here's a flashback for you. Think back to earlier in the year. If I gave you x squared plus 5x minus 14 all over x plus 7. And I said, simplify that. See what you would do. So go ahead and pause the video and try to work that one out. Now, hopefully what you realize is that you could just factor this thing and it would break down into x minus 7, x plus 2. The factors x minus 7 would cancel, and you're left with x plus 2. And hip hip hooray, it's considered to be simplified. Hopefully that's what you did. Now, realize what you're doing here is you could check that by saying, all right, these two are supposed to be equivalent. Where we started and where we finished are supposed to be equivalent, but this one is considered more simplified. Well, the nice thing about this version is it's much easier to do calculations, right? So if I said x was 5, would you rather plug in an x or 5 for x over in this equation and try to simplify it, or would you rather plug it in over here? And I think we'd all agree that plugging in a 5 for x in this equation would be a lot easier. So this is why we like him. He's more simplified. Now, that was the past. Let's jump into the future. I'm going to go right into an example. Our job is going to be to simplify. And what we're going to simplify has trigonometry with it, as you can imagine it. 1 minus the cosine squared theta times the secant theta times the cotangent of theta plus the tangent of theta times the secant of theta times the cosine squared theta. And our job is going to be to simplify that. And I'm sure you guys are like, oh my goodness, that is so nasty. And it is nasty. But the nice thing about it is I have some tips for you. We need some help to simplify this. We need what we call some identities. And so let's start out here. I'm going to give you two sets of identities. One group is what's called the reciprocal identities. These are going to be little rules, almost formulas that'll help us out here. Identities. The first one says, if you see the cosecant of theta, really you can replace that with 1 over, do you remember? Sine theta. So then secant, who do you think that is? Of course, that's 1 over the cosine. And if I say tangent, oops, I'm sorry. If I say cotangent of theta, we should know that's 1 over the tangent. Of course. No surprises there. Now, you also have a couple new ones. All right. These are the reciprocal identities, and I'm going to put a magic box around those. Let's see here. So we're going to need to remember those. But then we also have a couple new ones. Think about the tangent of theta. He's got his own identity. And if you think about the tangent, you remember that on the unit circle, the tangent of a given angle, so like the tangent of theta, would be the y value over the x value. Well, but you also remember that the y value is really just another way of finding the sine, and the x value is another way of finding the cosine. So you could define tangent as the sine over the cosine. And by the same result, you could define cotangent, since that's just the reciprocal of tangent, as cosine over sine. So those are our two new identities. Let me just move this little picture over here. So that's an identity for the tangent. Now we got one more group. And that group is called the, that group is called the Pythagorean identities. All right. Now, if you remember the Pythagorean formula, Pythagorean theorem says that for a right triangle, a squared plus b squared equals c squared. Well, when you're talking about trigonometry, the most basic Pythagorean identity says that sine of an angle squared plus the cosine of an angle squared equals, you would think it's tangent, but it's actually 1. Okay? That's the Pythagorean identity for trigonometry. Now, if you're wondering why that is, again, think about it on the unit circle, right? If I had an angle like this, okay, can you see there's the right triangle? Here's the x value, here's the y value. And remember that the hypotenuse on the unit circle is always 1. So really all you're doing is x squared plus y squared equals 1 squared. Well, x squared is cosine squared, the y squared is a sine squared, and 1 squared is just 1. So that's where this Pythagorean identity comes from. We're going to be using that one a lot. All right. Now, if you can remember this one, the other two versions of it are actually really easy to remember. So I'm going to do this in green. If you start out with the original sine squared plus cosine squared equals 1. All right. What I'm going to do is I'm going to divide that. I'm going to divide everybody here by cosine squared, which I'm allowed to do as long as I do it to every term in the equation. Well, now I see I can simplify this a little bit, because sine over cosine, is tangent. So that means tangent squared. Cosine squared over cosine squared, well, that simplifies down to 1. And 1 over the cosine, well, if I think back up here, is really the secant. So I can simplify this into there, and voila, I have a new identity. Okay, we're just making little rules for ourselves. Now, if I do the same thing, I'm going to go back and I'm going to start with the sine squared plus the cosine squared. But this time, instead of dividing by cosine, I'm going to divide by sine squared. Well, sine squared divided by sine squared is 1. Cosine over sine is the cotangent. Don't forget to square it. And then 1 over the sine is actually the same as the cosecant. So these are my Pythagorean identities. 1, 2, 3. So let's put a little magic box around that. Okay. So these are going to be our little rules that are going to help us solve these problems. All right, so let's use these new identities and come back to our problem. You see, we were supposed to simplify all this mess, right? Let me see if I can be slick with it. And I'm going to copy this so I don't have to rewrite it here. All right, so there we go. So remember, that's what we were supposed to do. We're supposed to simplify all this mess. Well, let's use some of these identities that we got. First off, here's a dead giveaway. When you see somebody getting squared and you see a 1 involved, might help if you think about our friend, the Pythagorean identity. Can you see that if here, let me just do a little shortcut here. The Pythagorean identity, and yes, you're going to have to memorize this, says that sine squared, let me do a little thought bubble here on the side. Sine squared plus cosine squared equals 1. Well, ours doesn't say that. Ours has 1 minus cosine squared, but do you buy that you could just take this one and subtract cosine squared from both sides? And it's almost like you have a new identity that sine squared equals 1 minus the cosine squared. Right? So what I just proved is that 1 minus the cosine squared equals the sine squared. Really, and all I did was I subtracted cosine squared from both sides here. So that says that I can replace this with sine squared. So now I got, okay, well, that's just the same as sine squared. And we know secant is really 1 over the cosine. So I'm going to replace secant with 1 over cosine. And I know cotangent is really cosine over sine. Let's just keep going, and then we'll simplify. Hey, tangent might help me if I change this to sine over cosine. Secant I know is 1 over cosine, and then cosine squared. I don't have anybody for cosine squared, because if I try to use this Pythagorean formula again, then I would end up with, like, sure, I could say cosine squared is 1 minus the sine squared, but that's going to make it more complicated, not more simplified. So I'm just going to leave that as cosine squared. Now, if you look at what we have here, I see a cosine in the bottom and a cosine in the top. Well, those are going to cancel out. I see 2 sines in the top and I see 1 in the bottom. Well, that's going to leave me with just 1 in the top. So now this whole left side reduced down to just sine of theta. Now over here on the right, I got 2 cosines in the top, but I also have 2 cosines in the bottom. Well, that works out kind of nice, because then I can just, oops, it's like green here. Because then I know, okay, there's 2, and there's 2. So really, these guys all cancel out, and I'm left with just the sine. So I got sine of theta plus sine of theta. Well, when you think about, here's a little thought bubble. What's x plus x? 2x, of course. So sine plus sine is just 2 sine. And that is about as simplified as you can get it. You can't get any more simple than that. And wouldn't you much rather do calculations with this than with all of this mess? But really what turns out is that they're exactly equivalent, which is kind of funky. How's that? All right, so let's try some U-tries here. This next one's going to be a doozy, but see if you can do it on your own. And then I'll come in and give you an explanation here in a second. But this one, let's do secant of theta times the cotangent theta all over 1 minus the sine of theta. And we're going to subtract the cosecant of theta over 1 plus sine theta. All right. So go ahead and let's see if I can find something funky here. All right. So this is that time where I want you to pause the video and see what you can do on your own. Hit it. All right. This one's a doozy. So what I'm going to do is let's fly through it step by step. Secant is 1 over cosine. Cotangent. It's cosine over sine. I can't do anything with 1 minus sine because it doesn't have a squared, so I just got to leave that the way it is. All right? I go over here to the right side, cosecant is 1 over sine. And again, I can't do anything with the 1 plus the sine because it's not squared, so I can't use my Pythagorean identity. Here, though, since I'm multiplying, I see a cosine at the top, I see a cosine at the bottom, so really I'm left with 1 over the sine over 1 minus the sine. And over here I got, we're subtracting this whole thing, 1 over the sine over 1 plus the sine. And I'm almost to a stumping spot. It doesn't look like I can go anywhere else. I mean, yeah, I could change these to cosecants, but it's still not going to help me get these two together, except, remember that old song? What does the left side need that the right side has? In order to subtract these two fractions, I need a common denominator. Well, this is 1 minus the sine. That's 1 plus the sine, so I'm going to do 1 plus the sine of theta. And I'm going to, on this side, I need 1 minus the sine of theta. But you can't just do it in the bottom. You got to do it in the top. So now when I multiply these together over here, I'm going to just go back to red. I'm going to have, multiply these together, I'm going to have 1 plus a sine of theta over sine of theta. That's just in the numerator. And I'm going to be subtracting 1 minus the sine of theta times 1 over the sine of theta. Is going to look like that. Now they have the common denominator of 1 plus the sine of theta times 1 minus the sine of theta. Okay. Well, lucky for us, I got a fraction within a fraction, but these already have the same denominator. So that's easy. I can just go ahead and combine those together into 1 plus the sine of theta minus, now I need to take this whole group, 1 minus the sine of theta. I don't want, if I don't put this bracket here, you might think that you're just subtracting the 1, but you're really subtracting 1 and you're subtracting negative sine, right? So I'm subtracting that whole group, and that's going to be over sine because I had a common denominator. And then the bottom here, you guys okay if I go ahead and FOIL this? 1 times 1 is 1. Outside's going to give me negative sine. Inside's give me positive sine. So together those cancel out. And then the last give me negative sine squared. Okay? So now, up here, well, I can just go ahead and combine my like terms up here in the numerator. 1 minus 1 is 0. Sine minus negative sine, be careful here, is actually 2 sine, right? Because minus a negative is really like adding a positive. If it helps you, don't be afraid to do the keep, change, or ding dong, whatever you want to call it. So I got sine plus sine is 2 sine. 1 plus negative 1 is cancels out. So I got 2 sine over sine. These cancel out. And I'm left with just 2 in the top. 1 minus the sine squared. Think back to that Pythagorean identity. It's got sine squared with it. Sine squared plus cosine squared equals 1. If I subtract sine squared from both sides, then I realize that cosine squared equals 1 minus sine squared. So I can replace this with cosine squared. So really, I end up with 2 over cosine squared. Now, for me, you can leave it like that. You could also, perhaps, if you don't like the fact that there's still a fraction there, remember that when you're dividing by cosine, that's the same as the secant, right? 1 over the cosine is the secant. So 2 over the cosine squared is really 2 times the secant squared. And that is way more simplified than where we started. That's a doozy. If you can do that one, you can do anything. All right, let's do one more you try, and then I think you'll be ready for your homework. So this time, let's do, let's see here. Let's do this in the back. Example 3. Let's do the sine theta times the cotangent of theta all over secant squared minus tangent squared. Okay. Go ahead and try that one, and I'll meet you at the finish line. All right, check to see. Is that what you got? All right, that's pretty much it. I think you're going to be prepared as long as you work these out. Try those U-tries on your own. Come in ready to take a quiz tomorrow. Remember, it's open notes, so you can print these out or you can bring in your own, and you'll be good to go. Cheers.